Here we have our relay and base. So the relay obviously plugs into the base and clips onto the DIMM rail, which makes life nice and easy. And if the relay itself actually packs up, which is not that uncommon to be honest, it's easily replaced without having to rewire the entire thing. So that's the advantage of actually having the base. So on the left is a duplication of what's actually printed on the side of the relay. Now for some reason they use really faint ink on these drawings and then go and print it onto a transparent background as well, so making it what could already be a bit of a pain to read the diagrams, even worse by not printing it very clearly. So I've actually taken this from the data sheet, the diagram on the left, which obviously is far clearer and hopefully makes life much easier. So on the right is the actual picture of the base as well. We've got to remember that when the diagram on the left is the actual pins on the bottom of the relay. So when it's flipped over, obviously number 1 then transfers to the right hand side when it's plugged in. So that's the other thing to remember with this. So what we've got here is two sets of contacts on this relay. So our common would be coming in on number 5. Our normally closed contact is between 5 and 1, and our normally open contact is between 5 and 3. Same with the other side, 6 and 2 normally closed, 6 and 4 normally open. So when the relay coil is energized by applying a voltage between, in this particular case, 7 and 8, the relay is energized, it pulls in, and on both of these sets of contacts, the normally open contact will become closed. So 5 and 3 will be made, 6 and 4 will also be made. Here we have our schematic for one of the solutions to our problem. Now this one uses 2 relays and the 2 PIRs as discussed in the challenge. So PIR A is obviously on wall 8, so if someone walks past this, this will actually close. So what we said on the top row here is PIR 8, normally open contact, so if someone's walked past it, that closes, and then we can see on the right that the lights on wall A will come on, and it will also energise relay 1. Any contacts assigned to relay 1 will also close. So then on the second row, just the same again, PIR on wall C, someone walks past it, that closes, lights on wall C come on, relay 2 closes. And then on the bottom row there, we can see that as per our relay diagram, we've got the set of changeover contacts down there. So the contact for relay 1 will actually close, and that will bring lights B on. Now what we're relying on here is the timers on the respective PIRs. So relay 1 will remain energized for as long as the PIR timer continues. So in our case we did say we was going to set it for 10 minutes. So PIR A will run for 10 minutes and then it will open up again unless somebody walks past. So that will bring lights A on, and as we're required, lights B. And then likewise on the very bottom of the diagram, because we've energised relay 2 in the second line, that will close, and that can also bring B lights on. So that's an AND condition, sorry, it's an OR condition at the bottom. So if relay 1 is closed, or the contact for relay 2 is closed, the lights on the B wall will also be on. So in the next diagram we'll have a look how this is actually wired up. So here we're actually looking at the wiring diagram for the PIR and into the relay base, which is obviously where the connections are. So I will, incidentally, if anyone's wondering, this is Microsoft Visio, which is quite good for sketching. You can actually take photographs, which is effectively what the picture of the relay is, and the relay base of photographs, and we can actually add connection points to it, as we'll see now. So when the PIR is energised, we want it to energise the coil of the relay. So this is the live, which we're going to take, if we remember, if we look on the diagram on the left, number 7 will be our live. And then if we look, we need number 8 to be our neutral. So we'll connect that. Try and connect it. So we won't connect it. So we'll take that there. That's the neutral. We'll just move that over so it's a little bit clearer. That's that. So PIR closes, energises the coil of the relay. So we need, on this side of the switch, we need the actual feed, a permanently live feed coming out of here. And that, if you remember, we're going into terminal 5. So that will be our normally open contacts between 5 and 3. And number 3 is already in, that's going out to the lights. And that is it. So nice and easy when you can actually see the diagram. And obviously you have to understand that we need to be the live side with this, and then the switch side goes to the coil. So hopefully that makes sense. Any questions, please? If it doesn't make sense, I need to be hearing about it. Thanks a lot. Cheers.